Hello, welcome to part 2. So in the first part we imported the types and the methods we needed in our IL code, and this time we're actually going to put together a basic program that's going to print out something like hello world on the screen. So we return back to where we were, and we just got around to importing the various types and the methods, and so now we're in a good position to start with the program. So in this case our project name is going to be something like hello world, so the program we're going to generate is going to be hello world.dll. So let's work out where we can place that first of all. So we're going to put it into our project folder. Oops, folder. And we're going to call it project name .dll. And the first thing we need to do is actually define the name of the assembly. So the definition of the assembly has both a name and a version. So assembly name definition. So the name of our assembly again is going to be project name, and we're just going to have a single version. So what do we have on here? Yeah, 1.0.0. Looks good. So now we've got the metadata, we can now actually go off and create our assembly. So we can use assembly definition .create assembly, and this takes a few arguments. So it takes in our name we've already defined, the module name, so we're only going to have a single module, so that can be the same as our project, and the type of application we're creating, which is going to be a console application. And this returns a assembly definition itself. I think if we look at the definition of, you can see it's iDisposable, so we need to wrap that in a using as well. Okay, so what else do we need? So we've only got one module in there, which is our main module, so we'll have a reference to that. And when we added these methods before, we didn't do anything with them, but now we actually need to import them into that module so we can use them. So I'm going to change our code around slightly and pass in an extra parameter, which is the module we import them into. So module, so we then do module.import reference . So that imports the method into our module so we can use it, and that now returns a method reference rather than a method definition. And we need to do the same with our overload up here. Okay, so we've created our assembly, and we've allowed the methods to be used. So the next thing is we want to create our program class within the assembly. So this is going to be a type definition, which again has quite a few arguments. So we don't care about the namespace. The name will be program. And then we've got some attributes to, so whether it's a private or public, sealed or so on. So in this case it's going to be, it's not public, and it's sealed. And then finally what we're going to inherit from. So we want to inherit from an object. So that's going to be module.type system.object. We've got nothing lower than that. And now we've defined our program class, we can add that to our module as well. That's type. So we've now got a class, so we need a method, we need a main method within that class. So it's not a type definition, this time it's a method definition. And the method's called main. It's private and static. And it's never going to return anything, so that's going to be a void. Because main methods can return integers, but in our case we're never going to do that. And then what we do is we add that method, methods, to our class. And we need to tell it that this is the entry point to our application. So our assembly definition dot entry point is our main method. So that's the one that runs automatically when the program starts. Yes, so then the last thing we do is we'd actually generate the program, so that would be write, which is write in fact, and the name of the file we're going to write, which is up here. So I'm not sure whether this was run, but this would generate a program which did absolutely nothing. So at a minimum, what we wanted to do is print something on the screen. So we need to generate some IL. And the way we do that is you have to use we have to generate our IL processor. So that's a processor for this method. So this allows us to emit commands for the main method in our class. So IL stack based, so in order to call a method such as writeLine, you have to put the arguments, you're going to pass that method onto the stack first. So that's what we're going to do. So we're going to do IL.emit, and then you can remit the IL code we need. So in this case it's opcodes. And the code we're interested in is loading a string into the stack, which is load string. And the value we're going to load is whatever we want to print out. So I think for the moment, let's print out the name of our program, which was up here somewhere, project name. So it's hello world, I expect, in our first example. So that loads hello world, or the string hello world, onto the stack. So we can now call a method. So the thing we're going to call is our write string, which is our write method. No, it's not. It's writeLine, isn't it? And then finally, all methods have to have a return at the end. So let's add that in, which is this get. Let's say just to prove it to ourselves it's definitely working. Okay, so it didn't crash writing it, that's a good start. Sometimes it can even error at this point if you get things totally wrong. So that should be in our samples folder, hello world. So that's the file we just generated. However, it won't run at the moment because it can't find the runtime config JSON file. So what I'm going to do is just copy the one we had before from our C# version, just to get things working. So that tells it where the framework details are. And there is our program working. And We can probably load that into our spline. Let's move on some last time. And this is the program we just generated, and as you can see we've got our method, our main method, and now our free command to be generated. So next time we'll start actually generating the IL code we need for our program itself.